The atmospheric conditions at a specific time and place, like raining and cold. Weather. Weather is the state of the atmosphere at a particular time and place, including temperature, humidity, wind, and precipitation. Imagine standing in front of your closet in the morning, trying to decide what to wear based on the day's plans. It's similar to checking the weather, where you assess what's happening outside, such as rain and cold, to prepare accordingly. Just as you consider the day's events, like a meeting or a casual outing, to choose your outfit, you look at atmospheric conditions like precipitation and temperature to decide if you need a raincoat or a sweater, highlighting how both scenarios involve evaluating current conditions to make practical choices. The amount of water vapor in the air humidity. Humidity is how much moisture is present in the air around us. Imagine trying to fit all your clothes into a suitcase that seems just a little too small. Just like the suitcase has a limit to how many clothes it can hold, the air has a limit to how much water vapor it can contain. Humidity is like the fullness of that suitcase. The more water vapor in the air, the closer it is to being full, just as a suitcase gets heavier and harder to close as you pack more clothes into it. A measure of the amount of water vapor in the air compared to the maximum possible at that temperature. Relative humidity. It tells us how full the air is with water vapor compared to how much it could hold at that temperature. Imagine trying to pack a suitcase for a long trip, but you only have a limited amount of space available. This is similar to how the air can only hold a certain amount of water vapor at a given temperature. Just like how you have to decide what clothes you can fit into the suitcase without overstuffing it, relative humidity measures how much water vapor is in the air compared to the maximum it can hold at that temperature, indicating how full the air is with moisture. The constant movement of water through Earth and its atmosphere by evaporation, condensation, and precipitation. Water cycle. The water cycle is the journey water takes as it changes form and moves from the ground to the sky and back again. Imagine you're trying to manage a wardrobe that's always overflowing with clothes, yet you can't seem to find the right outfit when you need it. This scenario is similar to the water cycle, where water continuously moves through its various stages, just like your clothes cycle through different states of being worn, washed, and stored. In both cases, there's a constant flow. Evaporation is like taking clothes out to wear, condensation is like washing and drying them, and precipitation is like putting them back in the wardrobe, ready to be cycled through again. The temperature of air at which condensation begins. Dew point. The dew point is the temperature at which air becomes fully saturated with moisture, causing water vapor to condense into liquid droplets. Imagine you have a cup of water and you're slowly adding sugar, stirring each time. At first, the sugar dissolves easily, but eventually you reach a point where no more sugar will dissolve and it starts to settle at the bottom. This is similar to how the air can hold moisture. The air can hold water vapor until it reaches a specific temperature, called the dew point, where it can no longer hold all the moisture, causing condensation to occur. Just like the sugar reaches a saturation point in the water, the air reaches a saturation point at the dew point, where excess moisture turns into droplets, just as excess sugar settles out of the solution. A huge body of air with similar temperature and moisture throughout. Air mass. An air mass is a large volume of air in the atmosphere that has uniform temperature and moisture. Imagine opening your closet and finding all your clothes are the same color and fabric, making it easy to decide what to wear. This is similar to how an air mass functions, as it is a large expanse of the atmosphere where the temperature and moisture levels are uniform throughout. Just like your closet full of identical outfits provides consistency and predictability in dressing, an air mass offers a consistent weather pattern over a large area, as it maintains the same temperature and moisture characteristics throughout, much like the uniformity of your clothing. The boundary between two air masses of different temperatures is called an air front. An air front is where two different air masses meet, often causing changes in weather. Imagine you're at a crowded party where half the room is filled with people who love dancing and the other half with people who prefer sitting and chatting. Just like how the dancing enthusiasts and the chatty sitters create a noticeable divide at the party, an air front is the boundary where warm, energetic air masses meet cooler, more stationary ones. In this analogy, the dance floor represents the warm, active air mass. The sitting area symbolizes the cooler comet, calm air mass, and the boundary where they meet is the air front, much like the line dividing the dancers from the sitters. A long period of unusually low precipitation. Drought. Drought is when an area gets much less rain than usual, causing water shortages. Imagine you're trying to save money for a big purchase, but your income suddenly drops, causing you to spend more than you earn each month. This situation is similar to a drought, where the income is the precipitation we receive, and it's suddenly much lower than usual, while our expenses are the water needed by the environment. Just as your savings dwindle when you're not earning enough to cover your expenses, a drought occurs when the environment doesn't receive enough precipitation to sustain its needs, leading to a depleted savings of water in the ecosystem. A period of unique climate caused by the tilt of the Earth as it revolves around the Sun. Season. Seasons are the four divisions of the year marked by changes in weather and daylight, resulting from the Earth's tilt and orbit around the Sun. Imagine trying to stay comfortable when you have a fan blowing directly at you from different angles. Just like the fan's changing position alters how you feel its breeze, the Earth's tilt changes how sunlight hits different parts of the planet as it orbits the Sun. This tilt, much like the fan's angle, results in varying intensities of warmth and light, creating the unique climates we experience as seasons. The average weather conditions of an area over a long period of time. Climate. Climate is what you expect in terms of weather patterns over many years in a specific region. Imagine trying to figure out someone's personality by observing them only on a single day. Just like a person's true character is revealed by their consistent behavior over time rather than by their mood on any given day, the climate of an area is understood by examining its weather patterns over a long period, not just a single day. In this analogy, the single day is like a short-term weather event, while the long-term observation of mood and behavior parallels the study of climate, which requires looking at average weather conditions over many years. The effect of Earth's rotation on the direction of winds and current Coriolis effect. The Coriolis effect makes moving air and water turn and twist, causing winds in the northern hemisphere to deflect to the right and in the southern hemisphere to the left. Imagine you're trying to walk in a straight line on a spinning carousel. Just like how you find yourself unintentionally veering off course due to the spinning platform beneath you, the Coriolis effect causes winds and ocean currents to curve as they move across the spinning Earth. In this analogy, the carousel represents the rotating Earth. Your intended straight path mirrors the intended straight line movement of winds and currents. And the unexpected curve in your path illustrates how Earth's rotation diverts these natural flows, creating the Coriolis effect. a band of high-speed wind between the troposphere and the stratosphere. Jet stream. Jet streams are fast-flowing air currents in the atmosphere that influence weather and climate patterns. Imagine you're trying to navigate through a crowded shopping mall on a busy weekend, where people are moving at different speeds and directions. This situation is similar to how the jet stream operates, as it is a fast-moving band of wind that flows between the slower-moving layers of the troposphere and the stratosphere, much like trying to find a clear path amid the bustling crowd. Just as finding a fast-moving lane among shoppers can significantly speed up your journey through the mall, planes can utilize the jet stream to travel faster and more efficiently across long distances. An instrument that measures wind speed, anemometer. An anemometer is a device used to measure how fast the wind is blowing. Imagine you're trying to gauge how busy a restaurant is just by driving past it. This is similar to how an anemometer measures wind speed by observing how fast the wind causes its cups or blades to spin. Just as the number of cars in the parking lot can help you estimate how crowded the restaurant might be, the speed at which the anemometer's components rotate provides information about the wind's velocity. An instrument that measures air pressure. Barometer. A barometer is a tool used to determine atmospheric pressure, helping forecast weather changes. Imagine you're trying to determine if it's going to rain by feeling the heaviness of the air around you. This is similar to how a barometer works, as it measures the weight or pressure of the air. Just as you might feel the air getting heavier before a storm, a barometer detects changes in air pressure to predict weather patterns, with the air's weight acting as a clue, much like the way your senses perceive the heaviness in the atmosphere. An instrument that measures temperature. Thermometer. A thermometer is a device used to measure how hot or cold something is. Imagine trying to decide what to wear based on the weather outside. Just as you check the sky and feel the air to gauge if a jacket is needed, a thermometer measures temperature by responding to changes in its environment. The thermometer acts like your senses, detecting how hot or cold it is, and then provides a clear readout just as you make a decision based on your observations. A storm with lightning and thunder. Thunderstorm. A thunderstorm is a weather event characterized by the presence of lightning and its accompanying sound, thunder. Imagine being at a party where two people are having a heated argument, and everyone around is tense, waiting for it to escalate. Just like how the tension in the room builds and finally erupts into loud voices and dramatic gestures, a thunderstorm forms when atmospheric tension builds up between warm, moist air and cooler air above, eventually releasing its energy as lightning and thunder. In this analogy, the warm, moist air is like the initial disagreement. The cooler air represents the opposing perspective. The building tension is akin to the rising atmospheric instability, and the outburst of the argument is similar to the dramatic release of energy through lightning and the sound of thunder. A spinning funnel-shaped column of wind, tornado. A tornado is a powerful rotating storm that extends from a thunderstorm cloud down to the ground, causing intense wind and damage. Imagine trying to untangle a mess of earphones that have been shoved into a pocket. Just as those earphones twist and turn into a chaotic knot, a tornado forms when differing wind speeds and directions cause air to spiral into a tight rotating column. The tangled earphones represent the swirling winds, with each loop and twist akin to the tornado's spinning funnel shape, both resulting from conflicting forces, creating a spiraling motion. A large rise in water levels caused by hurricane waves and winds. Storm surge. Storm surge is the abnormal increase in seawater level during a storm due to strong winds. Imagine trying to carry a stack of papers across a windy parking lot. Just as the wind can lift and scatter your neatly piled papers, a hurricane's powerful winds and waves can push vast amounts of ocean water ashore, leading to a storm surge. In this analogy, the papers represent the water in the ocean, and the wind in the parking lot acts like the hurricane, forcing the water to rise and flood areas that are normally dry. The region 66 north and south of the poles that is never warm. Polar zone. The polar zone is the icy cold area around the north and south poles where the sun's rays are weak, leading to low temperatures. Imagine trying to warm up a room when the heater is only on the opposite side of the house. Just like the room struggles to get warm due to the distance from the heat source, the polar zones at 66 degrees north and south of the poles never get warm because they are far from the equator, which is like the Earth's heater. In this analogy, the equator acts as the central heating system, the warmest point on Earth, while the polar zones are like the distant room, too far from the heat source to ever truly warm up. Zone of moderate climate between the tropical and polar zones. Temperate zone. The temperate zone is a region on Earth where the climate is mild and experiences 4 distinct seasons. Imagine trying to find the perfect room temperature that isn't too hot or too cold, but just right for comfort. This is similar to the temperate zone on Earth, which lies between the extreme climates of the tropical and polar zones. Just like finding that sweet spot on your thermostat where you feel comfortable, the temperate zone is a region where the climate is moderate, providing a balance between the heat of the tropics and the chill of the poles. The climate within a small area that differs from the surrounding climate. Microclimate is a localized climate that can vary significantly from the larger area around it due to specific conditions like terrain, vegetation, or water bodies. Imagine trying to find a warm, sunny spot in your house during a cold winter day. Just like how that one sunny corner of your room feels noticeably warmer than the rest of the house, a microclimate is a small area with a climate that differs from its surroundings. In this analogy, the sunny corner is the microclimate, providing a unique environment within the larger, cooler climate of your home. Much like a microclimate provides a distinct weather pattern within a broader, different climate zone. A worldwide climate change caused by an increase in the Pacific Ocean's temperature. El Nino. El Nino is a natural climate pattern where warmer than average sea surface temperatures occur in the Pacific Ocean, affecting global weather. Imagine you're at a party and someone accidentally turns up the thermostat, causing the entire room to heat up. Just as the rising temperature in that room affects everyone inside, making them uncomfortable and sweaty, an increase in the Pacific Ocean's temperature during El Niño affects weather patterns across the globe. In this analogy, the thermostat represents the ocean's temperature, and the room's uncomfortable guests symbolize the worldwide climate changes triggered by El Niño. A worldwide climate change caused by a decrease in the Pacific Ocean's temperature. La Niña. La Niña is a climate pattern where the sea surface temperatures in the central and eastern Pacific Ocean become cooler than average, impacting global weather patterns. Imagine you're in a room where someone suddenly turns the air conditioning way down, making it uncomfortably cold. This drop in temperature not only affects how you feel, but also changes the dynamics in the room, like causing people to huddle together for warmth or even make different choices about where to sit. Similarly, La Niña involves a decrease in the Pacific Ocean's temperature, which, like the air conditioning, leads to wide reaching effects on global weather patterns, causing shifts in atmospheric behavior just as the cold air causes shifts in how people behave in the room. A long period during which ice sheets cover large parts of Earth. Ice Age. An ice age is a time when global temperatures cool and large areas are covered by ice sheets. Imagine trying to clean a room that slowly gets messy over time, with clutter accumulating in corners and on surfaces. This is similar to an ice age, where ice sheets gradually cover large parts of the Earth, much like the clutter taking over your space. Just as the scattered items in your room slowly expand, taking up more space until it feels overwhelming, ice sheets grow and extend, dominating vast areas of the planet until the climate shifts and clears them away, much like tidying up resets your room. The warming of the Earth when the atmosphere traps heat like a blanket. Greenhouse effect. It is a process where certain gases in Earth's atmosphere trap heat, keeping the planet warmer. Imagine trying to fall asleep on a hot summer night with a thick blanket covering you. Just as that blanket traps your body heat, making you feel warmer, Earth's atmosphere acts like a blanket by trapping the sun's heat. In this analogy, your body is the Earth's surface. The trapped heat is like the sun's radiation, and the blanket represents the gases in our atmosphere, which trap heat and warm the planet, illustrating the greenhouse effect. A large tropical storm with winds of more than 74 miles per hour. Hurricane. A hurricane is a powerful storm system with strong winds and heavy rain that forms over warm ocean waters. Imagine you're trying to organize a large group of people for a surprise party, but everyone has their own ideas and moves in different directions. This chaos is similar to how a hurricane forms, as warm ocean water fuels the storm, causing individual wind currents to spiral and combine into a powerful system. Just like how the group needs coordination to successfully pull off the party, a hurricane requires these wind currents to align and organize into a cohesive, swirling mass with winds exceeding 74 miles per hour, creating the intense tropical storm. A line on a weather map, connecting points with the same air pressure isobar. An isobar is a line on a map that shows where the air pressure is the same at different locations. Imagine trying to find a group of friends in a crowded park where everyone is scattered, but they're all playing the same song on their phones. Similarly, an isobar on a weather map connects different locations that share the same air pressure, much like finding those friends by following the sound of the same song. Just as you would navigate through the park by listening for that specific tune, meteorologists use isobars to navigate weather patterns by connecting points of equal atmospheric pressure. A line on a weather map connecting points with the same temperature. Isotherm. In science, an isotherm is a line on a map that shows areas having the same temperature at a given time. Imagine trying to adjust the thermostat so that every room in your house feels equally comfortable. This is similar to how an isotherm works, as it connects all the locations that share the same temperature on a weather map, much like ensuring every room is at the same desired warmth. Just as you want each room to have the same cozy temperature, an isotherm links points that have achieved this temperature balance, creating a comfort zone across different areas. A scientist who studies weather meteorologist. A meteorologist is a scientist who analyzes and forecasts the weather. Imagine trying to decide what to wear without knowing if it'll be sunny or rainy today. Just like how you try to predict the weather to dress appropriately, meteorologists study various atmospheric conditions to forecast weather patterns. In this analogy, your decision-making process is like a meteorologist's work. Both involve gathering information to make informed predictions about future conditions. Water that falls to Earth in any form, like rain, snow, sleet, or hail. Precipitation. Precipitation is when water from clouds falls to the ground as rain, snow, or ice. Imagine you're at a party with a variety of drinks being served, but you're not sure what you'll end up with in your glass. Just like the uncertainty of which drink you'll receive, precipitation involves different forms of water falling from the sky, such as rain, snow, sleet, or hail. The connection is that just as a party guest might receive any beverage from the selection, the Earth can receive any type of precipitation depending on the atmospheric conditions, with temperature and air pressure acting like the bartender deciding what gets served. A storm of swirling air with a low pressure center. Cyclone. A cyclone is a large, powerful storm system with strong winds rotating around a central low pressure area. Imagine you're at a crowded party and someone drops a tray of snacks in the middle of the room. Just like people rushing toward the snacks create a swirling crowd, a cyclone forms when air rushes toward a low pressure center. In both cases, the movement is driven by the attraction to the central point. Hungry guests seeking food at the party mirror air molecules moving toward the low pressure area, resulting in a whirl of motion around that core. An electric discharge caused when charges jump within a cloud, between two clouds, or between a cloud and the ground. Lightning is a sudden flash of light in the sky caused by electricity moving in the atmosphere. Imagine you're at a party where everyone is having a great time, but there's one person who suddenly feels a strong urge to sneeze. This buildup of pressure and the eventual sneeze is similar to how lightning works, where charges accumulate within a cloud or between clouds and the ground until they suddenly discharge. Just like the tension and release of a sneeze, lightning occurs when the electrical charges build up to a point where they can't hold back anymore, resulting in a sudden leap of energy to restore balance, much like a sneeze releases the built-up pressure in your nose. The distance in degrees north or south of the equator. Latitude. Latitude is an imaginary line that measures how far a location is from the equator. Imagine you're trying to figure out how far you are from your favorite coffee shop in the city. Just like you measure the distance to understand how far you are from the shop, latitude helps us measure how far a location is from the equator on Earth. In this analogy, the coffee shop represents the equator, the city map represents the Earth, and the degrees of latitude are like the distance markers that tell you how far north or south you are from the equator, just as you measure blocks or miles to the coffee shop. The process of a gas changing into a liquid. Condensation. Condensation is when water vapor in the air cools down and turns back into droplets, like on a cold glass. Imagine trying to fit too many clothes into a small suitcase before a trip. As you pack, the clothes get compressed and squeezed tightly to fit into the limited space, much like gas molecules cool down and come closer together to form a liquid. Just as the clothes change from a loose pile to a compact bundle in the suitcase, gas molecules transition from a freely moving state to a denser liquid form during condensation. Winds circulating against the rotation of the Earth, they have a high pressure center. Anticyclone. An anticyclone is a weather system where winds spiral outward from a high pressure area, often bringing clear skies. Imagine you're trying to organize a group of friends to go out for dinner, but everyone is suggesting different places and times, causing a bit of chaos. This situation is similar to an anticyclone, where winds circulate in an organized manner around a high-pressure center, much like how you need to create a central plan to get everyone on the same page. In this analogy, the high pressure center is your dinner plan that organizes the friends. To move in a specific direction, counter to the Earth's rotation, just as your plan counteracts the chaos and aligns everyone's preferences. The zone of warm climate that extends 23 north and south of the equator. Tropical zone. The tropical zone is a warm region around the equator with consistent weather where temperatures are generally hot year-round. Imagine trying to keep your living room warm during the winter when your heater only covers the center of the room. Just like the heater warms the area closest to it most effectively, the tropical zone, stretching 23 degrees north and south of the equator, is consistently warm because it is closest to the sun's direct rays. In this analogy, the heater represents the sun. The living room is akin to Earth, and the warmest part of the room, right in the middle, corresponds to the tropical zone where the sun's heat is most concentrated. The top of liquid changing into a gas. Evaporation. Evaporation is when a liquid turns into a gas, usually from the surface, when heat causes its molecules to move faster and break away. Imagine sitting in a crowded room, and gradually people start leaving one by one, making the room feel less congested. This is similar to how molecules at the surface of a liquid gain enough energy to escape into the air as gas, reducing the overall density of the liquid at the top. Just like people leaving a crowded room makes it less crowded, molecules escaping from the surface of a liquid into the air make the liquid level decrease, illustrating the process of evaporation. A wind that changes direction with the seasons. Monsoon. It is a seasonal weather pattern characterized by heavy rainfall and a shift in wind direction. Imagine trying to decide whether to use an air conditioner or a heater in your home, depending on the time of year. This decision changes with the seasons, much like how monsoon winds shift direction between summer and winter. Just as your choice of heating or cooling depends on the weather outside, monsoon winds change based on the temperature differences between land and sea. When it's hot, the wind brings rain from the ocean, and when it's cooler, it reverses direction, bringing dry air from the land. A chemical that causes ozone depletion, it is also known as CFC. Chlorofluorocarbon. Chlorofluorocarbon is a man-made compound used in products like aerosols and refrigerants that can damage the Earth's ozone layer. Imagine you have a small leak in your car tire that slowly lets out air, causing the tire to deflate over time. This situation is similar to how chlorofluorocarbons, CFCs, interact with the ozone layer in our atmosphere, gradually depleting it. Just as the tiny puncture in the tire leads to a slow but steady loss of air, CFCs released into the atmosphere break down ozone molecules, thinning the protective layer that shields Earth from harmful UV radiation. A measure of cooling, combining temperature and wind speed. Wind chill factor. It describes how cold it feels on your skin when the wind is blowing. Imagine sitting in a room with a fan on while trying to enjoy a bowl of hot soup. Just like how the fan cools the soup faster by blowing air over it, wind chill factor describes how wind makes cold temperatures feel even colder on our skin. The fan represents the wind. The soup is like our skin, and together they illustrate how moving air accelerates the cooling effect, making us feel colder than the actual air temperature might suggest. A wind that blows steadily in a specific direction over long distances. Global wind. Global winds are large-scale wind patterns that move across the Earth, influencing weather and climate. Imagine trying to navigate a crowded shopping mall where everyone is moving in the same direction towards a massive sale. Just as you find yourself being swept along with the flow of people, global winds consistently move in a specific direction across vast distances. The shoppers represent air molecules, and just like the organized movement towards the sail, global winds are driven by large-scale patterns, such as the Earth's rotation and temperature differences, guiding them steadily across the globe. A climate influenced by an ocean with warm winters and cool summers. Marine climate. A marine climate is where the ocean keeps temperatures mild and steady throughout the year. Imagine trying to keep the temperature of your home comfortable all year round using just one fan and one heater. Just as the fan and heater work to balance the indoor temperature regardless of the season, a marine climate is moderated by the nearby ocean, which absorbs and releases heat slowly. In this analogy, the ocean acts like the fan and heater, preventing temperatures from becoming too extreme by warming the air in winter and cooling it in summer, just as your home appliances aim to maintain a steady, comfortable environment. The climate at the center of a continent, with hot summers and cold winters. Continental climate. Continental climate involves large temperature variations between seasons because land heats and cools quickly. Imagine trying to maintain a comfortable temperature in a room that has no insulation and large windows on both the sunny and shaded sides. Just like how this room would heat up quickly during the day and cool down rapidly at night due to its exposure, a continental climate experiences extreme temperature variations because it's far from the moderating influence of oceans or large bodies of water. In this analogy, the lack of insulation and the large windows represent the vast landmass in the center of a continent that allows for quick heating in summer and rapid cooling in winter, leading to hot summers and cold winters, much like how the room's temperature fluctuates easily without external moderation.